Welcome to aminacademy.com. In fluid mechanics regarding flow through branched pipes, let us solve some problems. Look at this example. Three reservoirs A, B, C are connected by a pipe system as shown in figure. Find the discharge into or from the reservoir B to C if the rate of flow from the reservoir A is 60 liters per second. Find the height of water level in the reservoir C. Take F is, that is Darcy coefficient is 0.006 for all pipes. Here this pipe setup is like your reservoir A is in datum ZA and datums are ZB and ZD. Now applying Bernoulli's equation E to D. So A to D. Applying Bernoulli's equation to points E and D. This letter point is E and D. Flow A to D. Now applying Bernoulli's equation, that is flow through pipe here A to D, that is A to D are calculating, applying Bernoulli's equation from the point E to D, which is left side is ZA, then right side is ZD plus potential at point D over rho G plus HF1, where HF1 is 4 FLV square by D to G. Then first we'll calculate V1, velocity of the flow is Q1 by area A, which is equal, Q is 0.06 because then flow through 60 liters per second is 0.06 meter cube per second. Meter cube per second over cross-sectional area of the pipe is pi by 4 into D, diameter is 0.3 meter, 0.3 square, which gives is equal approximate 0.848 meter per second. This much speed it flows through the pipe 1. Now loss, that is losses of is formula is 4 FL V squared by D1 into 2G. 4 F is 0.006 into length of the piece 1200. V velocity is here, that is 0.848 the square over D, diameter 1 is 0.2, diameter 1 is 0.3 meter into 2 into 9.81 equal 3.518. Loss HF is this. Now applying the Bernoulli's here, that is ZA ZE equal ZT plus potential difference over rho G. Rho G plus H1. Therefore, ZE which gives then ZA is look at here ZA equal then here 40 meter given, then we can put it that 40 here, 40 meter is equal to ZD plus PD over rho G plus the losses 3.518. Therefore, 3.518 from this side is 40 minus 3.518 equal ZD. ZD plus PD over rho G. Then this is equal 40 minus 3.518 is 36.482 equal ZD plus PD over rho G. Now plus losses will be from this we can get it ZD then we can write it this one ZD PD is let it be P1 over rho G is equal 36.428. Here, hence piezometric head D is 36. Piezometric head is this one 36.482, but ZP is 38 meter. Here ZB is given as 38 meter. ZB is 38 meter. Piezometric. This is the piezometric head, but ZB is equal. We have piezometric head at D. Piezometric head at D is a piezometric head at D here, but ZB is 38 meter is given. Hence the water flow. Hence water flow from B to D. Here at B, piezometric head is 38, datum head is 38, and piezometric head is 36.482. Therefore, from B to D, the water flows. The direction is this way. B to D. Applying Bernoulli's equation from B to D. Applying Bernoulli's equation at B to D. Bernoulli's equation B to D. Then look at here, ZB, datum head, equal ZD plus PD over rho G plus HF2, the losses, or 38 is equal 36.482 plus HF2. From this HF2, we can calculate 38.48, 38 minus 36.482, which gives 1.518 meter is HF2. That means loss in this line is this much, HF2. Then we know that HF2 equal 4FLV square, that is V2 square L2 over D2 into 2G. Applying the values 4, this is 0.06 into L2. Pipeline L2 is 600 meter and V2 square over D2. Diameter is 0.2 into 2 into 9.81. From this calculation, that is here, which is equal 1.518. From this we can calculate V2. Therefore, V2 velocity of the pipe 2 is, which is 1.518 into cross multiplication 0.2 into 2 into 9.81 over 4 into 0.06 into 600 under the square root, because V square is given. By calculation, this gives V2 equal 0.643 meter per second. Velocity at the pipe 2 is 0.643 meter per second. Discharge, that is discharge through pipe 2, that is Q2 equal V2 into pi by 4 D2 square is equal, V2 is 0.643 into pi by 4 into D2 square. D2 is 0.2 square, which gives 20.2 liters per second. This we got. Next is applying Bernoulli's to D to C. Applying Bernoulli's to D to C. Look at here. Your D to C we are calculating now. D to C is ZD datum D plus PD over rho G is equal ZC plus HF3. Now Z is already we have 36.482 plus ZD is equal ZC now these two things, that is ZD plus PD over rho G is this, that is isometric head is equal ZC plus the losses HF3 is 4FL3 V3 square over D3 2G, which is equal then then here where V3 velocity at 3 is Q1 over pi by 4 D3 square. Then we are applying this V3 here. But from continuity, look at here, the branch is here. Look at here, and this volume flow through this one is distributed for these two pipes. No, here because volume flow through A to D, but this here already we have done B to D. The flow is B to D. That is this plus this is equal to here. That is we have to use this relation for continuity. From continuity equation, Q1 plus Q2 equal, look at one more time here, this already we found this flow is from B to D, and that is B to D and A to D combining together go to D to C. Therefore Q1 plus Q2 equal Q3. Therefore Q3 is 0.06 plus point already we have 0.0202, which is equal 0.0802 meter cube per second. We got Q3. Then velocity V3 equal Q3 is 0.0802 over pi by 4 into 0.3 square, because this D1 is 0.3 square. Now is equal, by calculating this gives 1.134 meter per second velocity we found. Now applying this equation, velocity we found, then further we are applying 36.482 is equal ZC plus the losses for F is 0.006 into length 800 into FV is 1.134. 1.134 squared over 0.3 diameter, which is 2 into 9.81. From this relation, calculate this and collecting this side, we get ZC is equal 36.482 minus this value gives 4.194 equal 32.288 meter. That is, look at here, ZC we calculate ZC, that is datum of point C is this. We calculated the required things now. You have done. Please subscribe our YouTube channel.